Alrighty, in our previous video we found that the Thevenin equivalent voltage, V Thevenin, was equal to 6.25 angle 51.34 degrees. And once again, I'm going to be using this kind of shorthand notation of representing the polar coordinates of the impedances and the phasors, as opposed to writing 6.25 e to the j 51.34. Alrighty, with the Thevenin voltage, we need now simply determine the Thevenin equivalent impedance. And we're going to do that each of three different ways. This first method is what we'll refer to as the equivalent impedance method. It works when we have only independent sources or no sources. This equivalent impedance method that we're going to show first does not work if the circuit you're analyzing has dependent sources. So our approach, or this approach, requires us to deactivate any independent sources present. In this case, there's an independent voltage source here, which we deactivate by turning it to 0 and thus replacing it with a short circuit. And then looking back into the circuit from the terminals A, B, and determining what the equivalent impedance is that we would see looking back in that way. Well, hopefully you can see pretty easily that with the source deactivated, replaced with a short circuit, it brings this capacitor and this resistor into parallel. And that parallel combination is in series with the J50 ohm resistor, such that the impedance seen looking back into these terminals, Z Thevenin, will equal Z parallel plus the J50 ohm inductor. So Z parallel is equal to 20 times minus J25 divided by 20 minus J25, which turns out to equal 12.2 minus J 9.8 ohms. So finally, Z Thevenin then is equal to ZP 12.2 minus J 9.8 plus the J50, and that then equals 12.2 plus J 40.2 ohms. Z Thevenin, bringing it up here then, rewriting it just to show what we've got, or to show our complete model. Our complete model involves the Z Thevenin equaling 12.2 plus J 40.2 ohms. And our claim then is that this Thevenin equivalent circuit has the same terminal characteristics at the AB terminals as our original more complicated circuit.